Hello, welcome to this video. This one's a little bit different. This is not focused on any sort of exam prep for your CRTP or OCP, anything like that. This is actually on game hacking, something I'm quite passionate about and do a lot in my spare time. I thought I'd try and start making some content on it because it's quite popular. And in this one, we're going to be going over function hooking. So in this, I'm just going to demonstrate how you can hook DirectX 9 from Steam. So basically the Steam overlay actually hooks into various graphics engines such as Vulkan or DirectX, all different versions ranging from like DirectX 8 to DirectX 12 being the most recent. And what the Steam overlay will do is it will hook these functions, which basically takes the output or the execution, from them, and it goes to the overlay's custom internal functions. And I'm going to show you multiple ways that you can sort of use that to your own advantage. It should go without saying, just in case you're unfamiliar with this kind of topic, all the things that she demonstrated in this video, none of it is going to cover any sort of anti-cheat or evasion, things like that. This is just a very basic primitive example. These are by absolutely no means undetected in any sense of the imagination. So yeah, just if you're watching this as a beginner and think, oh, I'm going to break games, you're correct, but you're not going to get very far. There's a lot more to it than just this, but this is a nice little example, and it's a good little intro to reverse engineering. It's nothing too mental. So I've opened this up in IDA, which is a static analyzer. So if you're unfamiliar with this kind of thing, this is basically just decompiling and breaking down the code into the instructions, and IDA's a really good tool. It actually reconstructs it as well for you, which is incredibly powerful. Without this sort of functionality, it'd make reverse engineering infinitely more difficult. But I'm not going to go too much into things like that, but just for people who are a little bit uninitiated or just beginning into this sort of thing, this is sort of the industry standard. You want to use something like IDA. You can use tools like G-Hydra, things like that as well. I prefer IDA. I think it's much better. It's just my tool of choice. But so right away, I've just loaded up the game overlay renderer DLL inside of here. So if we boot up a game, I'm using Castle-Z as an example. And so unfortunately, as you just heard a little bit there, I didn't have my headphones on whilst I was actually doing this, so the game volume was actually muted. So instead of having that annoying noise, I'm just going to do a voiceover now and just sort of show you what is actually going on. So all I'm doing here is just showing you the different where I found that the game overlay render was hooking these sort of functions. So initial knowledge of it, although I've never done it, it's pretty obvious what's going on and that they are going to be hooking something. But basically, whilst I was going through Castle-Z, I found a lot of these functions were getting hooked by game overlay renderer. So I thought, we'll go through different attack paths, and I'm just going to demonstrate now sort of where some of these hooks are. So there's one in present, and there's one of a few of the virtual functions as well, the ones I found, but the ones I found were in the create device function and in present. The main ones, obviously present's going to be for your rendering. If you're not familiar with DirectX, you get your NC and your present. They're the two functions that are going to or two main ones that are going to actually give you some sort of output to your screen, and your Direct3D create function is going to be what's going to be create your Direct3D9 device, and that's needed to actually use some of these functions, things like that. And that's all I'm just going through here really is I'm just going through the strings now, sort of showing you sort of how you can see what the function actually is. So as you can see there, it sort of says that this is our Direct3D create function. It's pretty obvious what's going on. So after this, we just went to IDA and just had a quick look to see what was actually going on. So as you can see, now I've opened things up in IDA, we've just been put into our entry point function. So if you were to open up the game overlay render module, this is similar to what you'd see. You might see it in graph view. I'm just in the decompiled view here. But now I'm sort of just been going through is sort of how we're going to go about finding these functions and sort of how we're going to hook them. So all I'm doing now is just stepping through the functions. We're just going to try and find the main function essentially. So as you can see, a lot of these look very similar to your function or your decorations for when you actually create a DLL, like your DLL main, things like that. And as you can see here, we've just found it, and this will be our DLL main as I'm going through now. And I'm just going to sort of show how we can get to an interesting place from DLL main. Basically, obviously, if we start right from the bottom, in reverse engineering, that's generally a good approach. It's just going to be quite a lengthy approach, and there are shortcuts to this, as I explained in this initial video. So initially how I actually found these functions was searching through strings, but this is just another way you can do it, and that's all I'm showing now. I'm basically just going through sort of explaining what it's doing here. So it's quite obvious it's hooking certain things from specific modules, such as user 32, native DLL, and kernel 32 as well. Obviously Steam's interested in these functions, and it's trying to import use of them, because obviously it needs to actually use them. And as we keep scrolling down, we're going to find a fairly interesting bit at the bottom here in a second, which is sort of going to give us a bit of an indication or sort of where we want to look next. All I'm sort of going through here is just the thought process behind these functions. So what this is basically saying to us, or what we can see here, is that hooking function being called, and there we can see straight away, if we're familiar with this, that this is actually going to be a hooking function. As you can see from the text there, couldn't get trampoline region lock. If you're not familiar with function hooking, a trampoline hook is a type of function hook, and it basically just means going from one back to the other, similar to a trampoline, going back and forth. And as we can see there, right underneath it, it's going to be our hooking function from when we see that string. So if we're going to rename it just so we don't lose it, and we're going to call it our hooking function. We can always change the name later, but this is just a good way to sort of keep track of things as you're going through quite a big program like this. And in a second, this video is just going to take a big skip, because it took me quite a while to actually find where I was, because initially, as I already explained, this is not how I sort of found my way to these things initially. But all I'm going to do is just step through each one of these function calls and sort until we find something interesting, and then I'm going to explain sort of how and why it actually is particularly of interest to us, and what's actually caught my eye about it. So coming back, this is the function that initially caught my eye when I was going through. Reason being, there's a few key things here, as I'm going to put my cursor on in a second. If we see there, just where there is a long point of void, or there we can sort of see that's a V table. In case you're not familiar, that's dereferencing a V table. Basically, that's accessing from the object. And the reason that's caught my eye is 'cause I've been sort of familiar with them or playing with them recently. Obviously, if you're not familiar with these things, you're not going to spot that. But that's just one sort of key way we can sort of spot that is probably where we want to be looking. As well, we can sort of see it's also indexing some key functions here. Now I know just from past experience that at an index of 17, that is going to be our present function, and if we step into some of these functions inside of IDA, which I'm going to go through in a second, we can see that these functions are going to sort of resolve to the present function NC and things like that. Basically, the vtable pointers are going to point to these functions, so we know we're in the right track. Right now I'm trying to find the present function in x86 debug, and is also failing to do so. So I've just gone back here, and we're just going to step in and see sort of what's going on here. So we're stepped inside of what we don't know yet is the present function. This is the, as you can see at the top there, look at the function prototype, as I'm going to pull up now, and see how similar they are to the present function from MSDN. So if we look at the arguments, we have 2 pointers at the start, handle to our window, and then another pointer at the end. And if you go back there, you'll also see there's an extra argument at the front. So some might think, oh, that's not the right function, but if you're not familiar with reverse engineering, when you are calling from an object or a virtual table, it's going to actually also have this pointer, and that is the pointer to the object that's called it, basically the Direct3D9 interface. So yeah, that's why the extra argument is there at the front. So we can sort of say beyond a reasonable doubt, this is the present function, and this is where it's being hooked, basically. We've found it. And all we're going to do now is just go through the function and rename some types just to make it a little bit easier for us. So right now I'll rename the function in case we lose it, and for whatever reason we have to go back and try and find it. We don't got to do that, we can just search it up. And now, as we know that's a V table, we can probably rename the variable and change its type, and IDA will auto-complete some stuff for us, which helps us out quite a bit. And as you'll see in a second, I do make a mistake, and I do misinterpret what's what, but IDA helps me figure that out, as you're going to see. So right now, all I'm doing is just renaming or giving this variable a different type. So I actually get these mixed up. I'm calling this the device pointer when this, in fact, this is the device v table. And the reason why I can figure that out is because you see at the end, it's sort of accessing it as if it was an object and not a pointer. It's sort of saying, there we go, from one of those functions, it's then accessing the v table, which is incorrect, so it doesn't look quite right. And if we just swap the two types around, so the Direct339 device and the Direct3D9 device v table, then we can see in a second sort of what happens when we do that. IDA sort of figure it out. Now all I'm saying is sort of how we can also find this function, how we confirm that this is actually where we want to be. So there's only 3 functions where this function that's stored is being called, and as you can see, every single time it's got something to do with creating a Direct3D9 device. So we're on to something here, and the only time this function is being called is after the device is created. So we can sort of say beyond a reasonable doubt that something's happening here. Once the device is accessible, then we can start hooking functions, and we can start putting things in place. Exactly what Game Overlay Render's doing here. So we can sort of say this is definitely the right place to be, beyond a reasonable doubt. This is where we want to be looking. This is where we want to. This is where our hooks will be placed, essentially. As you can see there, that's our hook in place function. It's not a trampoline function. This function is not actually inserting the trampoline. It's not the code to do it, but this is where it's saying, oh, we want the hooks placing at this place, that kind of thing. As you can see here, I'm sort of figuring out now that these are the wrong these are the wrong types, and that I'm swapping them around now. And you'll see in a second that after we change them, things do look a lot better. All I'm going through now is just the actual hooking function. We're just figuring out sort of how it works and what the parameters are going to be. So as you can see there, the first argument will be the function that's going to be hooked, and the second argument is going to be where the function's getting detoured to, and then the third argument will be the return address. So that'll be the pointer to the original function. So the original present function pointer we're going to store in that variable at the end, and then we're going to execute that once we're finished. So that's basically how the trampoline is going to work. It's going to go to the hooking function, and then it's going to go back to its original place. As you can see now, I'm changing the types, got figured out it don't look quite right. And you're going to see in a second that it looks a lot better, and it's a lot easier to read. I just picked up on that because it just looks a bit weird, it's not normal. And as you can see, once we change it, it'll look a bit better. As you can see straight away, after changing the types and getting them correct this time, we can see that IDA is automatically resolved from its symbol information that this is in fact the present function, that we are correct in our assumption that present's being hooked there, and also the other functions getting hooked as well, such as reset, and I've forgotten actually what else is there, can't quite read it, reset and release, sorry, other key functions as well, and also some swap chain stuff as well. All things that are going to be needed when we're doing some or interacting with these sort of devices, drawing to the screen and things like that. Basically just create things more stable, all the utilities that we're going to need. And that's all that Steam's doing here. It's just taking all these utilities and hooking it inside their own module. Now all I'm doing is just going through the hooking function and just sort of renaming these variables here, just so it's for our benefit, just in case we get confused. So as you can see there, the functions to be hooked, and then this will be where we're going to play, or where the function getting hooked is going to, so our hooking function. And then the third argument will be the return address, so the address of the original function. We need that because obviously we need to know where we're going to go back to from our trampoline. This will all become clear in a later video that I'm going to do. If you're not familiar with trampoline hook, there's plenty of articles and videos on it online, but I'm also going to do one as well. So if you're interested, do wait out for that, and I'll be showing you how I can create our own, things like that, both in x64 and x86. Obviously for the start, we're going to start out x86. It's a little bit easier. In x64 things get a little bit different, but nothing too major. Okay, so as I was just saying before, so I had to restart my IDA. I had a little bit of an issue there. If we were confused or we were in doubt anyway with what we found, thinking that, is this actually, what we think it's going to be? Is it going from X, Y, and Z to here? One way we can check that is by getting the address of this function, however we want to do it. For instance, a relative offset here, and we'll go back into dynamic sort of analysis tool like x86 debug, things like that, and we'll actually go to the address that's there. So if we go to this address, it takes us this function here, and off the bat we can't really see too much from the function. We could do some more digging. Nice, quick and easy way I'll sort of gauge what a function is based on my knowledge of it. Breakpoints, really nice and easy. If we take this breakpoint off, the game runs as normal, no dramas. But if we put a breakpoint on, this is called every frame, or present is called every frame. That's what's going to draw to the screen. Same with end scene. So if we put a breakpoint on end scene, as you can see straight away, it's because it's just in a loop. It'll just constantly hit the breakpoint. So if we go back to where we just were, put another breakpoint on it. You can see it gets hit every frame. There's no skipping a beat. So we can sort of say confidently that that's sort of what it's doing. And we can always try it. We can go dig a little deeper, or we just write some code and just sort of see what it's doing. So going back in IDA, we are pretty happy with what's going on here. Hooking function, just insert a trampoline in the present function from DirectX 9 or our DirectX 9 device. It's going to the hooking function inside the game overlay module, and then it's executing the original function. That's basically how trampoline works. A few different ways we can go and attack this. We could just hook this function and bypass everything, or we could use what they've given us and we could hook the function hooking, or just take the function hooking utility, hook their present function, and then divert executions to our own custom function, and then back to the address of their function here in the game overlay renderer, which is exactly what we're going to do. So I'm going to talk you through that now. So as you can see, I've restored some offsets and stuff up here. I'm just going to slow time, just really slowly go through the code, just to give you a little introduction, just to sort of see what's going on. Again, this is not a masterclass now to write good C++ code. Quite frankly, this is not the greatest code in the world. It's just an easy, just a demonstration of how you can achieve something like this. So inside our hook present function from overlay, we're basically passing it our module base. So this is going to be where the game overlay renderer module is actually loaded inside our process, basically. So if we go here, a few things going on, and we'll talk through it line by line. We're getting the address of the hooking function, so the function that actually inserts the trampoline, which is this one here, that we've named hooking func. We're just going to basically take this function and just use it. We're going to reference it in our own code, basically. And then we're going to get the present function. So we're just taking, if we go to this address here, as we've just been to in x82 and then 230 there, this is all we're going to do. We're hooking that present function, that overlay function, so we can redirect our execution from it. So once we've found those two things, we can then get the hooking function and basically make it accessible to us. So what we're going to do is we're going to declare a function prototype and assign a pointer to it. I'm going to show you another way to do this in another video. This is like a quicker, more shorthand way of doing it. I don't really like this way of doing things. It's harder to read, but it's just how I decided to do it here. Where's it gone? Hooking function. Here we go. So basically all we're doing is we're declaring a function prototype here. So if we look in IDA, the function is returns a chart, or return an address, a pointer to somewhere. Calling conventions cdecal, so we'll specify that there. And then we're just going to name our or give it our parameters, basically. So function being hooked, destination, and the return address, and we're not too sure what that is. Pretty sure it's a bool or something to do with it. I didn't play around with it, but everything else is calling it, it always remains one. It just remains static as one. So we're just going to do the same as we do down here. Once we've sort of found this function and sort of reference it in our code here. This is basically saying take this pointer and assign it to this variable. So now this variable becomes a function, basically. It becomes a function pointer. So when we call this function, it'll be referencing the internal function inside of Game Overlay Renderer module. So as you can see, we're taking the original Game Overlay function inside our Game Overlay Renderer module. We're then going to take it to our custom function, present func hook. Here we go. And we'll just draw a line, dead easy, just a nice little demonstration, better than doing some text so you can actually see it. And then the return address will be the original function, which I for some reason cannot find. There we go. So again, it's another function prototype. So instead of it being our hooking function, it's going to be the actual original present function. So as well, it's a bit different. So as we can see, their hooking function, or present as well, as we know from before, it takes 4 arguments. These 4 here, but because we know, because of how calling conventions work, things like that, at this point it will always be called first. So that's why this Direct3D Dx9 pointer is there. And then all we're going to do inside our hook is just call the original function. So we're going to execute the code that we want, and then we're going to call the original function using all the parameters. And that's about it. It's fairly simple, nothing too complex. And we're not having to write our own trampoline code because we're just using Steam's. So in reality, you could get away with, well, pretty much 1, 2, 3, 4, 5, 6, if you really wanted to. Essentially less than 10 lines of code. And we've just stolen the Game Overlay Renderer's code. So if we just build this, and we'll inject it into Castle Miner and just sort of see what happens. Is it because we have a debugger attached? I'll just get rid of this debugger. Sometimes it breaks when that's attached. And we'll inject it into a fresh process. As you can see there, present function's been hooked. A nice little line drawing in the corner there. Nothing much else to it, but yeah, that's just how I've gone about doing that. As I say, this is not the only way to achieve this. You could hook the present function, inserting your own trampoline, but why do it when there's this already there for you, kind of thing. It's nice and easy enough to do. So yeah, hopefully this was interesting, and just one way in which we can sort of hook and draw with DirectX 9. So thank you for watching.